out there, far beyond Pluto, far beyond the Kuiper Belt. In the cold, silent emptiness between the stars, a tiny human-made object continues its lonely journey. This is Voyager 2. Launched in 1977, it's been traveling for nearly half a century. It's a relic of our past, a testament to our curiosity, a whisper of our existence sent into the cosmic ocean. For decades, it has sent back postcards from the outer planets, Jupiter, Saturn, Uranus, Neptune. It showed us worlds we had only dreamed of. Now it drifts through interstellar space, the vast abyss that separates our solar system from everything else. It is the farthest active probe we have, a ghost from home haunting the cosmic dark. To understand the significance of Voyager 2's current journey, we must travel back in time, back to the 1960s and 70s. This was the golden age of space exploration, a time of bold ideas and cosmic ambition. An aerospace engineer named Gary Flandreau made a remarkable discovery. He realized that in the late 1970s, the outer planets, Jupiter, Saturn, Uranus, Neptune, would align in a very special way. This alignment happens only once every 176 years. It created a unique opportunity. A single spacecraft could use the gravity of each planet to slingshot itself to the next, like a cosmic billiard shot. This was the Grand Tour. NASA seized this once-in-a-lifetime chance. The agency designed two of the most robust and sophisticated probes ever conceived, Voyager 1, Voyager 2. Their mission was nothing short of epic. They were tasked with exploring the gas giants of our outer solar system up close for the first time. The mission was an unprecedented success. What does it mean to be in interstellar space? What does it mean to be in interstellar space? Imagine our sun as a giant campfire. It radiates heat. It radiates light and a constant stream of charged particles known as the solar wind. This solar wind carves out a massive bubble in the cosmos called the heliosphere. This bubble is our home. It's our solar system's protective shield, deflecting a significant amount of harsh galactic cosmic radiation. For billions of years, everything we knew existed inside this bubble. But beyond it lies a completely different environment, the interstellar medium. This is the space between the stars, filled with gas dust and radiation from countless other suns and cosmic events across the galaxy. Voyager 2 officially crossed that boundary, the heliopause, in November 2018. It plunged into the cosmic ocean. The data it sent back was immediate and profound. Its instruments detected a sharp drop in solar wind particles and a dramatic spike in high-energy galactic cosmic rays. The signal arrived at the Deep Space Network's Canberra complex in Australia on September 4, 2025, a faint whisper from the void. At first, the data stream from Voyager 2's plasma science, or PLS instrument, seemed routine. The PLS instrument is designed to measure the properties of plasma, the superheated gas of ions, electrons that fills space. It measures its density, temperature, and speed. For years, it has faithfully reported on the tenuous plasma of the interstellar medium. But this transmission was different. Embedded within the expected noise and standard readings was a pattern, a clear, repeating, and utterly unnatural pattern. It wasn't a complex message like a picture, a language. It was a simple, stark fluctuation in the plasma density readings. The instrument reported a sequence of density pulses, a sharp spike, a drop to near zero, another spike, another drop. The sequence repeated itself with mathematical precision. 1010. It was binary, digital, a fundamental language of computing. The pattern was external. The instrument was correctly measuring a binary signal being imprinted on the very fabric of space around it. The team at JPL immediately went into overdrive, trying to debunk the signal. Could it be an instrument malfunction? They ran every diagnostic in the book. All systems on Voyager 2 reported back as green. The PLS instrument was functioning perfectly. Could it be a reflection? Maybe some bizarre interaction between the probe and a previously unknown plasma field? The world's best astrophysicists modeled every conceivable scenario. No natural phenomenon known to science could account for such a clean, sustained binary pattern being imprinted on the interstellar medium itself. The signal wasn't just in the data, it was in the space that the data was measuring. Let's get one thing straight. Voyager 2 cannot see in the way we do. It has no optical camera capable of snapping a picture of a spaceship. Its imaging system was shut down decades ago to save power. Its instruments are designed to taste, touch, listen. The PLS instrument measures plasma density. So, what could create a 1-0 pattern? Creatively, one could imagine technology far beyond our own, something that could actively manipulate the density of plasma in a localized area. The news, when it finally broke, sent shockwaves through the scientific community and beyond. At first, it was just whispers on internal forums, then a leaked memo, and finally an official, cautiously worded press conference from NASA. Dr. Anya Sharma, the current head of the Voyager Interstellar mission, was the one who had to face the world's cameras. We have detected a repeating, structured anomaly in the plasma density data from Voyager 2. We have exhausted all potential explanations related to instrument error or known natural phenomena. We are, at this moment, investigating the possibility that this signal is of an artificial origin. The reaction was electric. Dr. Evelyn Reed, a leading SETI researcher, expressed what many were feeling. For 70 years we have been listening. We've pointed our telescopes at distant stars, hoping to catch a faint, stray signal. We never dreamed the first credible candidate for an artificial signal would come from something that found us, or at least our little robotic emissary. It's a paradigm shift. We were searching the cosmos, but it seems the cosmos may have been waiting for us to step outside. Her statement highlights a fundamental change in perspective. We are no longer just observers. We are participants. Of course, skepticism remains a vital part of the scientific process. Dr. Kenji Tanaka, a renowned plasma physicist, urged caution in a widely circulated op-ed. An extraordinary claim requires extraordinary evidence. While the signal is deeply perplexing, we must not jump to conclusions. We must remain objective and let the data guide us, no matter how strange. Humanity now stands at a profound crossroads. The Voyager 2 anomaly, whether natural or artificial, forces us to ask a monumental question. What do we do next? The debate is raging in government halls, scientific institutions, and public forums. One faction, the observers, argues for extreme caution. Their position is simple. We do nothing. We continue to listen and observe, but we do not reply. We don't know the nature of the signal or its source. Is it a greeting, a warning, or a trap? Sending a powerful targeted signal back would be like shouting in a dark forest where you know you are not alone. It's a risk we cannot afford to take. On the other side are the engagers. They argue that this is the moment we have been waiting for. This could be the most important discovery in human history. To remain silent would be a failure of nerve, a betrayal of our exploratory spirit. Dr. Sharma and her team are already working on potential replies. Not a complex message, but something simple. They propose using our most powerful radio transmitters to alter the interstellar medium in a similar way, to send back a 1011 sequence. A simple mathematical progression. So why do we do it? Why do we spend billions of dollars to send a tiny machine into the vast, empty darkness? Why do we strain to listen for a signal that takes almost a full day to reach us? The answer is as old as our species. It is written in our DNA. We are explorers. We are curious. From the moment our ancestors first walked out of Africa, we have been driven by an insatiable need to see what lies over the next hill, across the next ocean, beyond the next star. It is this very curiosity that defines us as human. Space exploration is not a luxury. It is an investment in the survival and inspiration of our species. The challenges of space travel force us to innovate, to create new technologies, and to push the boundaries of science. The knowledge we gain gives us a profound perspective on our own world. Seeing Earth as a pale blue dot, as Carl Sagan so eloquently put it, reminds us of our shared home and our responsibility to protect it. Exploration unites us. It gives us a common goal, a grand adventure that transcends national borders and political squabbles. It lifts our eyes from the ground and directs them to the cosmos. The journey of Voyager 2 is our journey.